Okay, this is the latching circuit I'm going to be using, and I'll explain why. This is going to be the power from our track, as we used before, and this second is to be power from a second power supply, which we're going to use. So we can control whatever voltages we want on our accessories, such as the crossing guard or the light thing, or whatever we want to power separately or isolate it. So first we're going to come down, we're going to start using relays, and I'm going to call them CR for control relays. And when the train hits the first control relay, it's going to fire this CR1, closing contacts. We're going to fire this next one called CR3, and it's the same thing. It's going to fire trigger by bringing power across the negative back to here, run back to positive, completing our loop. And that's the same thing. It's going to fire a pair of contacts. Down here is where our magic happens. We have this CR3, which is a normally closed contact we're using. Then we have CR1, the same as up there. That's a normally open contact. Then we have CR2, which is a new relay we just added using our separate power supply. This is normally open. And then we bring off CR2 coil, and then we can jump and run any kind of accessory we want through there, controlled by the voltage we want, isolate it from the track power. So what's going to happen is when CR1 turns on, it's going to close these contacts. Being that CR3 is normally closed, as long as our train's not sitting on CR3 signal, it's going to conduct power through here. CR1 is on. It's going to allow this to conduct electricity. And we're going to turn on CR2. Now this contact is going to be closed or be pulled in. So even if CR1 opens, it latched itself in. So this power will not go away until it's reset by CR3. If that makes any sense. So basically what we're doing, we're using this trigger through these two coil wires here and here. This is very crude, but this is going to be torn down probably as soon as I get done. It's going to control CR1 by track voltage. CR2 is this one. It's going to be controlled by a secondary power supply via our secondary transformer over there. CR3 is way over there by that little green building and that mountain thing, and the train's going to control that on. So what we're doing basically, building a latch, I brought in the negative side of the secondary power supply, brought in the positive side of our secondary power supply. This is going out via this white wire through this cable all the way over to our CR3 relay, coming back on this black wire to here. Then it's going to come out on this black wire here, around here into this contact for CR1, which is controlled by the track voltage but isolated due to the contact. Come out on this white wire into the coil control for CR2. So that's going to turn on CR2 and cause that relay to close. I have that power hooked to the upper contact, normally open contact, here, and that comes out on this side and goes back to our main power supply. So essentially what I'm doing is, again, wiring very crudely this circuit in. So when CR1 turns on, it makes that jump. CR2 comes in, it's automatically locked in, and it will not reset. Is what I'm doing. Now I have my output here, and it's going to run around for the positive side of our circuit to control our lights or our crossing guard, whatever you want to turn on. So what I'm going to do now, if I turn the train on over there, power it up, I have my secondary transformer turned on. What's going to happen, as soon as it hits this signal, both relays are going to come on. CR1 is going to turn off. If you notice, this one stays on. And our signal crossing guard stays on and our light stays on until CR3 is hitting over there by the train. And the train will come around. Maybe. And it's going to complete the process again by turning on our crossing guard, turning on our light, and then rolling around until it hits our CR3 contact over there. I'll bring this around one more time to see. Maybe I'll power up the train a little bit. I don't know why it's going so slow. You can watch it here. Signal. The latch circuit came in. And as soon as it hits CR3 over there, we'll see this light go out. And our things turn off. I'm going to stop the train right now. And I want to talk why this is useful. Again, we're isolating voltage, so we can run whatever power supply is. We have a second set of contacts in here, so we can run a higher voltage if we want. I don't like mixing those together, but we can do that if we need to. We can still use our momentary contact in here, because we have an extra set of contacts, which is nice. But the main reason we're going to do this is if I trigger our circuit, bring the train around again. We'll trigger it. Now, even if I stop the train anywhere before CR3 triggers, everything's going to stay on as long as I want it to. So if we're bringing our train into a yard, let's say for a switching track or something like that, whatever we hook up is going to stay on. So if we have a yard light or whatever accessory we want to stay on, we can run it. So if we're going to run a back-off track, run a side spur, a bypass track, we can do that, and whatever light we want on or accessory will stay on the entire time until our train again hits our second signal and turn off. Now the bad thing is if I ran this second train in this loop, which I'm not going to turn on, it's still going to hit this signal and turn it on. And it can go around and around and around all at once. But this will not turn off until it sees that signal over there. So that can be a drawback. But that's how that circuit's wired up. It's ugly, I know, but it's going to be torn down here in a few minutes. We can also latch using the track voltage to keep something on until it hits another point in the track. But using a track voltage to latch in, again, if you stop the train anywhere, that latch is going to be unhooked just because the power went away from the track itself. Maybe I'll wire that up. We'll see how much time I got before I tear this down to get to the next video. But any comments, let me know. I appreciate them.